Welcome to this MOOC on developing more complex mobile applications with Flutter. This course is the second part and a natural continuation of the first one on building simple apps. So, what's the difference? In the first part, we focused on simple widgets, basic graphical components, and on single-screen applications. For example, we all know and use simple calculator-style apps. In this second MOOC, we will address more advanced concepts. First of all, we will explore navigation between screens or pages. As mentioned, most of the applications we use every day consist of multiple screens, so we must be able to move smoothly from one to another. We will also move on to more advanced state management techniques. In the first part, we focused on individual elements with a single state component. In this course, we will move toward more complex scenarios where multiple stateful elements coexist on the same screen, and their behavior needs to be coordinated. Finally, we will look at more advanced features to provide a better experience for users interacting with our apps. Several new versions of Flutter have been released. Although we have always worked with the last version available, there are no major changes that we need to consider, and nothing that would invalidate what we have already built. We are all used to navigating when we use application, simply moving from one screen to another. There are many different gestures that allow us to switch between screens. The most common one is tapping a button, but we might also swipe or perform other touch gestures on the screen. The real challenge is not the gesture itself, but designing a clear navigation flow, a structure that users can easily understand and follow. Users expect navigation to be intuitive and predictable. When the flow is confusing or inconsistent, frustration quickly arises. Good navigation reduces cognitive load and allows users to focus on their goals instead. For this reason, navigation should remain consistent throughout the application so that similar actions always produce predictable results. In Flutter, navigation is not only a design decision, but also a structural one, since it directly affects how we organize routes within the application. In essence, there are three navigation patterns, each with different characteristics. In theory, they can be combined, but in practice, the key advice is to keep navigation as simple as possible. Simplicity not only improves usability, but also makes the application easier to maintain and evolve over time. The first pattern is the so-called stack-based navigation, which is used to create a flow between different screens or pages. It is called stack-based because, as we will see shortly, there is a stack working behind the scenes. Screens are placed one on top of another. The idea is to create a sequence of screens that guides the user through the various steps of a process within the application. A typical example is a checkout flow in an e-commerce app, where the user moves from the cart to the shipping details, then to payment, and finally to confirmation. An important aspect of stack-based navigation is backward movement. Since screens are stacked, users can usually return to the previous one by popping the stack. This reinforces a clear mental model. Each new screen temporarily covers the previous one, and going back restores it. We can have as many pages as we want. The navigation structure, often represented as a navigation graph, can be as simple or as complex as needed. The navigation graph is simply an abstraction of this idea. The nodes represent the different screens, and the edges represent the possible transitions from one screen to another. Our goal is to design something well organized and intuitive. We should always avoid sinks, meaning screens that users can arrive but cannot leave. At the same time, we should not create isolated screens because they would simply serve no practical purpose. In Flutter, this structure directly influences how we define routes and manage transitions between widgets. The second solution is tab-based navigation. Typically, this pattern uses a bar located either at the bottom or at the top of the screen. This bar contains several buttons or items that allow users to select a specific screen, or what we could call a specific section of the app. Many well-known applications are based on this navigation pattern. The idea is to provide a common framework that groups together a set of largely independent screens. As mentioned earlier, navigation patterns can be combined. For example, the tabs can represent the main entry points, and behind the scenes, each tab can manage its own stack of screens. In this case, the goal is not to create a complex sequential flow. Instead, we want to organize and group several mostly independent activities that users can access directly. The last option is the so-called drawer-based navigation. It's called a drawer because it works like a side menu that can be opened and closed, similar to pulling out a drawer. There are typically two ways to open it. Most apps provide a small icon in the app bar that users can tap to reveal the side menu. Alternatively, users can swipe from left to right to open it, just as if they were physically sliding a drawer open. Inside the drawer, we usually place the main sections or primary screens of the application. By selecting one of the menu items, users can jump directly to the screen they are interested in. From there, navigation can be organized using patterns we have already discussed: local menus, tabs, or stack-based navigation. Drawer navigation is particularly useful when an application has several sections that are important but not necessarily accessed in a strict order. However, it should be not overloaded with too many options, as this can reduce clarity and make the interface harder to use. It's important to remember that these three navigation patterns can be combined and integrated. However, these are the core principles, and our task as developers is to apply them wisely while keeping the overall navigation as simple and intuitive as possible. In Flutter, this means carefully structuring our widgets tree and declaring how the drawer interacts with routes and navigation stacks.